Lesson 5, Using Exponent Laws. Our goal today is to use all we know about exponents to simplify expressions and solve problems. We can use our exponent laws to simplify expressions that contain rational number bases. It is convection to write a simplified power with positive exponents. So whenever possible, we want to get rid of negative exponents. Simplify. Which exponent laws did you use? So let's look at the first one. We have a to the power of 5 times a to the power of negative 8. We're multiplying bases, so we're going to use our multiplication law. And our multiplication law says then that we need to add our exponents. So we're going to have a to the power of 5 plus negative 8. 5 plus negative 8 is negative 3. We want to write, whenever possible, our answers with positive exponents. So we need to deal with that negative. That negative says take the reciprocal of a, so we have 1 over a, and now my exponent is positive. So we end up with 1 over a cubed. The second one is going to use our division law. So we're going to have m to the power of 5 take away negative 3, or m to the power of positive 8. Be careful when adding and subtracting negative numbers. Part C is our power of a power law. In this case, we're going to multiply our exponents. So n to the power of 3 times negative 5. 3 times negative 5 is negative 15. Again, we want to write it with a positive exponent. So a negative in the exponent means take the reciprocal of the base. So we have 1 over n to the power of 15. In part D, we have a power of a quotient. So that exponent outside has to go to both bases, and we're going to multiply the exponents. So we have c to the power of 3 times negative 2 over d to the power of 1 times negative 2. Well, c to the power of 3 times negative 2, 3 times negative 2 is negative 6, and in the bottom, 1 times negative 2 will give us d to the negative 2. We want to write with positive exponents. So the negative 6 means take the reciprocal of c. So that's going to become 1 over c. So our c is going to move into the denominator and have now a positive exponent of 6. The d also has a negative exponent, so it's going to move into the top and become positive 2. Part E is a power of a product. So the 6 applies to both the a and the b. And again, we're going to multiply those exponents. So we have a to the 3 times 6 times b to the negative 2 times 6. 3 times 6 is 18. Negative 2 times 6 is negative 12. We want to write with positive exponents. So the a already has a positive exponent. I'm not going to do anything to it. But that negative exponent for b means make that 1 over b, or move b into the denominator. And we then have b to the power of positive 12. Part F, we're doing a bunch of multiplying, so I can multiply the x's together. If I multiply the x's, my multiplication law says that I need to add exponents. So x to the 3 plus 2. For my y's, I can add 2 plus negative 4. So I have x to the power of 3 plus 2 is 5. Y to the power of 2 plus negative 4 will be negative 2. Again, writing with a positive exponent, x already has a positive exponent, so I don't need to do anything to it. The y is to the power of negative 2, so it becomes 1 over y, or moves y into the denominator, and now my exponent is positive. Last one, I'm doing some dividing, so we can simplify our a's. If I'm dividing the a's, I subtract the exponents, so 5 take away 2. B's, I also subtract exponents, so 3 take away negative 2. 5 take away 2 will be a to the power of 3. 3 take away negative 2 becomes 3 plus 2, or positive 5. Both of my exponents are positive, and so that question is finished. The next group, these ones, we've got fractions and negatives. Same process, just more complicated because of the fractions. So in the first one, I'm multiplying my x's. I need to add my exponents. So I want to do 2/3 plus 1/3. If I add 2/3 plus 1/3, I get 3/3, or x to the power of 1. In the next question, it's a power of a power, so I'm going to multiply my exponents. If I'm multiplying 1/3 times 2/5, I multiply the numerators, so 1 times 2 is 2. Multiply the denominators, 3 times 5 is 15. In the next one, I've got some x's that are being multiplied together, so I want to add their exponents. So I have x to the 3/2 plus 1/2. I also want to add my exponents for y, which is 2 plus -1. For my x's, 3/2 plus 1/2 is 4/2. My exponent for my y, 2 plus a -1 is just 1. And so simplifying a little bit more, x to the power of 4/2 will simplify to just x to the power of 2. Y to the power of 1, and usually we don't write that exponent of 1. So here's my answer for part C. For part D, this -2 has to go to each base inside the brackets, and I have two bases. I have 3 and I have a. So I end up with 3 to the power of -2 and a to the power of 3 times -2. I'm going to simplify my a's first. So 3 times -2 is -6. Now I have negative exponents. The first one is 3 to the power of -2. That negative means make that 3 1/3, so it has to go into the denominator, and then I can square it. A to the -6 means that the a has to move into the denominator, and it's going to have a +6 as the exponent. You need to make sure this is the denominator, so make sure that it's 1 over those numbers. One last step in simplifying. I know that 3 squared is just 3 times 3, or 9, so I have 1 over 9a to the power 6. Part E, again, that 1/3 has to go to every base inside the bracket. So I have 8, A, and B. So I have 8 to the power of 1/3 times a to the power of, I'm going to multiply those exponents, b to the power of multiply those exponents. 8 to the power of 1/3, well, an exponent of 1/3 means the cube root of 8. A to the power of, I'm going to multiply 3 times 1/3, will just be 1. And b to the power of 6 times 1/3 will be 2. I can simplify the cube root of 8. The cube root of 8 is 2. If I rewrite a, we usually don't write the 1, so it's 2 times a times b squared. In part F, we're dividing, so we can start by dividing our numbers. 4 divided by 2 is just 2. Then I look at my a's. If I'm dividing a's, I need to subtract the exponent, so -2 minus 2. And with my b's, again, subtract the exponent, so it's 2/3 minus 1/3. 2 is simplified. A to the power of -2, take away 2 is -4. B to the power of 2/3 minus 1/3 is 1/3. The 1/3 exponent is okay, but I need to deal with the -4 exponent for my a. So that -4 will move that a into the denominator and make it positive. The 2 is still in the numerator, and the b to the 1/3 is still in the numerator. The 2 and the b didn't have negative exponents, so we don't need to move them. Okay, part G. I'm going to start by simplifying inside my brackets. So I have some numbers that I can divide. 100 divided by 25 is 4. I have a's on the top and the bottom, so I'm dividing a's. So I'm going to have a to the 1 minus 5. And I only have b's in the bottom, so we're going to leave them there for right now. So I have b to the power of negative 1/2. All of that is still to the exponent of 1/2. Let's simplify some more inside those brackets. So I can't simplify 4. A to the power of 1 minus 5 will be negative 4 over b to the negative 1/2. I could deal with the negative exponents now, or I can deal with them later. So I'm going to leave them for right now. Let's now deal with this exponent outside of 1/2. That 1/2 has to go to all three bases. So I have a base of 4, I have a's, and I have b's. So we're going to multiply their exponents. So 4 to the power of 1/2, a to the power of negative 4 times 1/2, all over b to the negative 1/2 times 1/2, right? Multiplying exponents. Simplifying, 4 to the power of 1/2 means the square root of 4. If I have negative 4 times 1/2, I end up with negative 4 over 2 or negative 2. In the denominator, I have b to the negative 1/2 times positive 1/2 will be negative 1/4. Can still simplify. The square root of 4 is 2. I have a to the power of negative 2. Remember, we want to get rid of that negative exponent, so that's going to make it 1 over a, or my a squared will move into the bottom. In the bottom up here, I have b to the power of negative 1/4. That negative exponent will move the b from the denominator into the numerator and make it b to the power of 1/4. That's as simplified as I can get with that question. So a quick summary. Negative exponents mean do the reciprocal of the base. Rational exponents, so fractions and decimals, convert to a radical number. For multi-step expressions, break into small steps and apply your exponent laws. Okay, time for you to try some practice. Try practice number 6.